Guten Tag, Frau Professor Brigitte Falkenburg. Ich freue mich sehr, Sie zu sehen. Ich danke Ihnen sehr dafür, dass Sie meine Einladung angenommen haben, ein Interview zu geben und über Ihre Forschungsarbeit zu berichten. Sie sind Deutsche. Deutsch ist eine sehr schöne Sprache. Wir werden jedoch auf Englisch sprechen, da nicht jeder Deutsch kann. So, I'm very happy to see you, Frau Professor Falkenburg. Thank you very much for accepting my invitation to give an interview and to tell about your research work. You have a PhD in physics and PhD in philosophy. Since 1997, you have been professor of philosophy and techniques, of science and techniques at the Technische University of Dортмуnd, Germany. You wrote or edited about 20 books and published more than 100 articles. Your last books include Kant's Cosmology, From the Pre-Critical System to the Antinomy of Pure Reason, 2020, Mythos Determinismus, wie viel erklärt uns die Hirnforschung in German, in English, how much myths of determinism, how much does the brain research explain to us? 2012, Particle Metaphysics, a critical account of subatomic reality, 2007. And as an editor, you also recently published Mechanistic Explanations and Physics and Beyond, together with Gregor Schimann, 2019. Why more is different philosophical issues in condensed matter physics and complex systems with Margaret Morrison, 2015. And from ultra rays to astroparticles, historical introduction to astroparticle physics with Wolfgang Rode, 2012. So, Professor Falkenburg, first of all, maybe a little bit personal question. You studied physics and philosophy at several German universities. You earned a 2 PhD in physics and in philosophy. How did you get started doing research in philosophy? Why did you finally choose philosophy?
First, thank you very much for inviting me to this interview. And now I immediately start with your first question. I always had 2 areas of interest from the very beginning of my studies, or almost from my times as a schoolgirl, I might say, so many, many years ago. And the first interest was to understand nature, and the second interest was to understand what is going on in society. However, my first interest, the interest of understanding nature, was much stronger, and so I studied physics. But when it came to quantum mechanics, after the pre-diploma, after 2 or 3 years of studying physics, it came to quantum mechanics, and I wanted to understand the foundations and started to read books on the philosophical interpretation of quantum mechanics, because the lectures of our professors at the Technische Universität Berlin, Technical University at Berlin, the lectures of the professors followed the philosophy, shut up and calculate. And I wanted to understand what's going on with this very strange and very abstract theory and its probabilistic interpretation. So first, I read the German translation of Blochinseff's Foundations of Quantum Mechanics, which is a materialistic approach to understanding the foundations of quantum mechanics. And a little bit later, I found Peter Mittelstädt's book, Philosophische Probleme der modernen Physik, Philosophical Problems of Modern Physics. And this was a Kantian approach to the foundations of physics. And so I became interested in Kant's philosophy. By the way, it's quite curious. It's amazing because Peter Mittelstädt's book was more or less the very first philosophy book in German language that I found in search for understanding the foundations of quantum mechanics. And 20 years later, I started to collaborate with him for 2 decades. And when I found this book, I had no idea that one day I would learn to know and work with this fantastic physicist and philosopher. Peter Mittelstädt. In parallel to my physics studies, at the Technische Universität Berlin, I attended philosophy seminars at the Freie Universität Berlin, Free University of Berlin, and started to read the works of the critical theory of the Frankfurt School. This was my second interest in society, and above all, the dialectic of enlightenment, die Dialektik der Aufklärung. After my physics diploma, for a while, for several years, I oscillated between physics and philosophy. And I was working for several years in parallel on my philosophy thesis on Hegel's and Kant's philosophy of nature, on the one hand, and on the other hand, in a scattering experiment of high energy physics that investigated the quark structure of the nucleon. The experiment was performed at Geneva at the pre-runner of the LHC, one of the pre-runners of these experiments. I did my physics thesis at the Institute of High Energy Physics of the University of Heidelberg, where I was living then. Finally, I managed to finish both theses. After, I should say that I needed 8 years for both of that. That in between, in addition, my son. Yes, 4 years for each of the theses, and 8 years in total, but in parallel, and in between also my son was born, who is now an adult, obviously. And finally, after finishing both theses, I switched definitely to philosophy and was working for several years with Erhard Scheibe at the University of Heidelberg. So much to your first question.
Yeah, thank you. Thank you. And what are the main directions of your research work, Frau Falkenburg?
My main directions of research are the philosophy of science, obviously, with a primary focus on physics, also obviously, and a second focus on neuroscience, because if you studied physics and philosophy and have done a lot of work in both fields, it's very easy to jump into any other field of research. And at that time in Germany, the debate on the results of brain research was going on between the philosophers and the neuroscientists. And it was obvious to me that one party did not really take up the questions and the concepts of the other party. And so I began to work through the brain research and its history from the point of view of philosophy of science, and wrote the book The Myth of Determinism in order to mediate between both parties. That was my main aim. I don't know whether I managed, but the book was really read by many people.
So it's a great book, yeah. I recommend it to everybody, actually, but it's in German.
It's in German, yes.
Yeah, and probably.
But there are other fields of research. The traditional philosophy of nature. Sometimes I'm still doing occasional work on Hegel, but mainly on Kant. Kant was my last book on Kant's cosmology. In addition, also the neo-Kantian philosophy of science from the Marburg school to Niels Bohr, the physicist Niels Bohr, and the Heisenberg school, to which Erhard Scheibe and Peter Mittelstädt belonged. In addition, I worked on philosophy of technology and the methods of natural science versus cultural and social sciences, a more recent interest. The two latter fields of research added to my former interest in philosophy of science as an offspring of my early interest in social philosophy, but also an offspring of a stay at the Institute of Advanced Study, the Wissenschaftskolleg in Berlin. There I participated, well, it was 25 years ago now, I participated in an interdisciplinary project, Models as Mediators, the role of models in physics and economics, together with Margaret Morrison from Toronto, who later became a good friend and who recently has died, unfortunately. So so much to your second question.
Probably your interest in Kantian and neo-Kantian philosophy is not only historical. And do you think that neo-Kantism has a future?
Yes, I think there's also there's been a lot of work on transcendental arguments, even though this is not directly related, perhaps. There's more independent discussion in analytical philosophy. But my main interest in neo-Kantian, my main systematic interest in neo-Kantian philosophy is perhaps in the methodology of the sciences. And this concerns the work of the Southwest School of neo-Kantianism from Wilhelm Windelband and Heinrich Rickert to Max Weber, the work on the distinctions between natural science and cultural or social science.
So maybe you cannot say that just you are Kantian. What is your philosophical position? Is it scientific realism? No, not really. Yeah, because in your book Metaphysics of Particles, you developed, it seems to me, something like a new kind of scientific realism. No, so or rather Kantian, your position.
Well, my position is close to Kant's position, but it's not identical, and I don't know what kind of ism I would defend exactly. Things are complicated. Kant did not take into account the experimental methods of physics. He just talked about experience in everyday sense of experience on the one hand, and the sense of experience related to Newtonian science on the other hand, but everything else he started to touch upon in his opus posthumum, but he really could not get into it. And physics has developed a lot. So on the other hand, Kant's empirical realism, to which I close, in one aspect never could really convince me, and this is a question about space and time as pure forms of our intuition. I'm thinking that space-time is something out there, and that is the framework of the universe in which we are living. And so my position is somewhere in between some version of scientific realism here and Kant's empirical realism there. It's hard to define because things are so complex.
Alles klar, yeah. But in general, how do you understand the scientific realism?
Pardon?
How do you understand the scientific realism?
There are different versions of scientific realism, that's obvious, and I would not defend a metaphysical realism in the sense of Max Planck, for example, who was almost a Platonist about the mathematical structure of the world. This does not really convince me because it's quite probable that our current physical theories are all wrong and only approximate truth, and that they have to be revised in the future. But also our methods to have a grasp on the structure of nature are restricted, and so there may always stay a very large gap between our theories and the real structure of nature. At that stage, perhaps an element of pragmatism in the sense of a person could come in, but I cannot go into this right now. I think that the isms are all simplifying too much the very complex access of this, which science has to the world. As far as I know, the structure of different sciences and the nature of experiments, all of our scientific theories are combining constructivist and empiricist features with certain crucial realistic aspects. And so, on the one hand, I'm close to Kant's empirical realism and also to Putnam's internal realism, but on the other hand, I also defend a kind of a bit stronger version of a scientific scientific realism. However, to a certain degree, I also maintain a correspondence theory of truth. Our theories are either true or wrong, even though we perhaps will never know. On the other hand, well, I studied a lot of Hegel, as you know, and it has to be learned from Hegel that we cannot jump outside our thinking, our concepts, and our language. So therefore, I only subscribe a correspondence theory of truth to a certain degree, but also not absolutely. And so somehow I'm between all isms, and so it's hard to argue in a very simplified way for my philosophical position.
So you don't like isms, you are between all isms, yeah?
Well, I like them, but I'm a pluralist.
Okay, it's good, yeah.
I like pluralism, that's the only ism I like.
Okay, so now there are so-called new realisms in continental as well as in analytic philosophy, as you know. Does it has any impact on philosophy of science? Do you think that scientific realism should be corrected, or philosophy of science should be corrected in light of new realisms?
As far as I know, the discussion, for example, Marcus Gabriel's book, this is again this kind of philosophy that has split off from the sciences and is arguing on a quite remote meta level. And to a certain extent, the new debate on new realism looks to me like old wine in new bottles. Okay. And I ask myself, why do so many philosophers keep trying to reinvent the wheel instead of building on the inside from earlier debates and taking up, for example, the debate between Max Planck and Ernst Mach from more than 100 years ago, that is very instructive still up to the present day, or the Bohr-Einstein debate on realism, that is very instructive with regard to the complexity of quantum reality, the complexity of the subatomic structure of nature.
You mentioned Marcus Gabriel. He's very famous German philosopher, yeah, very popular, very famous. He wrote a lot of books, and he's relatively young, yeah. So yes. He works at the University of Bonn, yeah. So yes. There are different interpretations of quantum mechanics. Which do you prefer, or maybe you have your own interpretation?
First, I should say that I subscribe the probabilistic standard interpretation of quantum mechanics, and I'm quite a skeptic of any further interpretation that invents or speculates about an additional structure of the world, be it hidden parameters or be it many worlds or all that stuff that cannot be tested experimentally. I have been an experimenter in physics, and so I'm an empirical realist. So I insist in a theory of quantum structures that is close to the experimental results. And what is close to the experimental results, these are the algebraic quantum structures, the uncertainty relations and all that, and the probabilistic interpretation. I think the only real progress that has been made in the field of real means physically based progress that is based on physical experiments as well, is the decoherence approach, because it is possible to test the effect of decoherence at the probabilistic level. On the other hand, to associate the decoherence approach to a many-world approach to quantum mechanics and to a quantum theory of the universe seems quite problematic to me. So what else should I say? My views are a little bit beyond the probabilistic interpretation of quantum mechanics, are close to Niels Bohr's complementarity view in a generalized version that takes more recent developments of quantum theory into account. including quantum field theory. According to Bohr, you have the incommensurability and the uncertainty relations for the spin components, angular momentum components, and above all, momentum and position. But from the point of view of quantum field theory, you have also uncertainty relations for phase and occupation number of a quantum field. So field strength and the where you are within the amplitude, and this has also to be taken into account, and so you need a generalized account of complementarity. On the other hand, Niels Bohr thought that the whole domain of quantum phenomena can be exhausted in terms of complementarity, and I don't think so. There are genuine quantum phenomena that are beyond the complementarity view of Bohr. For example, the Bose-Einstein condensate and other macroscopic quantum phenomena. So Bohr's complementarity view is a basis, but it does not exhaust the complete domain of quantum theory. On the other hand, there is no general interpretation that convinces me, and we are not able to get rid of classical physics in order to interpret the theory.
Maybe in a sense you prefer the Copenhagen interpretation, yeah?
One should distinguish between the minimal probabilistic standard interpretation here and the Copenhagen interpretation in Bohr's sense there. Some people also say orthodox quantum orthodox interpretation, and then they mean more or less the position of John von Neumann's book, which is also slightly different. So, but I would say that Bohr's interpretation of quantum theory, which is a genuine Copenhagen interpretation, even though in general it is not understood like that today, that is close to Kant's views about empirical reality, combined with some kind of perspectivism.
So you are pluralist about
the kind. Pardon?
You also said that you are pluralist, yeah? So about perspectives.
Yes. I'm pluralist about perspectives, and the perspectives are, well, they depend on our methods.
And also scientific theory, instruments, and so on, no?
Experiments, yes, the kind of experiment we perform. For example, we have one experimental device in order to measure the path of particles, and we have another experimental device, and we have to change our experiment in order to measure inference fringes. And if you attempt to combine both, we get some kind of strange mixture or intermediate stage between both kind of phenomena, and we have to talk about unsharp properties, which, however, have only a probabilistic interpretation too, and not for the single system. To talk about the quantum properties of single systems is quite difficult, except in the situation immediately after a measurement or after a well-defined preparation of a beam in a scattering experiment of particle physics.
So do you think that there are two different domains of reality, the classical and the quantum, and they are not reducible to each other? Or maybe in principle the classical is reducible to quantum?
There's a big reduction problem, but the delimitation between the classical domain and the quantum domain is absolutely fuzzy, and it cannot be determined theoretically. They are very big. They are macroscopic molecules, or almost macroscopic molecules that show up quantum effects, quantum interferences, for example, and So it's very hard to say where the domain of quantum theory ends and where the classical domain begins. This this always has to be carefully specified in relation to some kind of specific physical problem and experimental device.
Alles klar. And by the way,
but the reduction problem is much more complicated than people.
For example, did a lot in this domain. Yeah, Erhard Schreiber worked a lot on reduction. The problem of
yes, his book is also very complicated. I'm working right now on the translation. But I wanted to mention another point that Schreiber also does not tackle in his book. The reduction problem is three countries problem, like between French, Switzerland, and Germany. We have a reduction problem in physics between classical mechanics and electrodynamics, quantum mechanics, and thermodynamics. We have three theories, and one knows from phenomena like the Gibbs paradox that thermodynamics must be based on quantum theory. But it's not possible to derive the classical world from quantum theory plus thermodynamics, because thermodynamics also presupposes classical physics. It's quite complicated.
Yeah, that's true. Yeah, it's complicated.
Yes.
By the way, you said that Bohr is Kantian, yeah, or neo-Kantian, Niels Bohr.
Yes.
What about Werner Heisenberg? Because he's also his interpretation is also Copenhagen interpretation.
Yes.
So
it is quite close to Bohr's complementarity interpretation, and as Don Howard has shown, the very term Copenhagen interpretation is due to Heisenberg and not to Bohr. But Heisenberg also added an Aristotelian moment to the complementarity interpretation of quantum mechanics by in terms of potentiality and actuality.
Okay, that's true.
And on the other hand, it's obvious that Peter Mittelstadt's approach to quantum physics is neo-Kantian, and he was a pupil of Heisenberg.
Okay, thank you. And Professor Falkenburg, you wrote a great book, Particle Metaphysics. Do virtual particles exist? Are they real?
As isolated entities, they do not exist, but there exist collective effects that can only be explained in terms of virtual particles. The whole formalism of virtual particles is an approximation procedure. And I like to compare it with Ptolemy's planetary system. From the point of view from our terrestrial point of view, the planetary motions are very complicated, and Ptolemy had to invent a lot of cycles and epicycles and deviators and so on in order to approximate the real planetary motions. We know today that the real planetary motions are elliptic. There are ellipses around the center of gravity of the solar system. So Ptolemy's approach was an approximation procedure. And the single epicycles did not correspond to reality. They were just a mathematical instrument in order to approximate the integrate phenomenon. And I think it's quite similar with virtual particles. And the main problem is that we have no mathematical access to describing isolated particles, including all of their self-interactions.
Okay, thank you. So, in your book, Mythos Determinismus, in English, Myths of Determinism, You criticize neuroscientific determinism and reductionism about the free will, but also about consciousness in general, and in particular about phenomenal consciousness. What is your position about the nature of consciousness? How do you understand the so-called explanatory gap problem or HAT problem in philosophy of mind?
I think we have no idea what consciousness is. I have to say in advance. And I just mentioned that the reduction problem is already very complicated within physics, and that it is impossible for the moment with the methods which we have to reduce the classical world to quantum structures or vice versa, and with the additional problem of thermodynamics. But in physics, we have a very nice constituent model of matter. That matter consists of atoms. Atoms consists of electrons and nuclei, and the nuclei consist of quarks, and with additional contributions to their dynamics and their mass also of gluons, their interaction particles, their virtual interaction particles. And we have some rules. We have some rules for mass and energy. We have some rules for charge, and we have some rules for angular momentum and spin, and so on. And we can exactly calculate how the mass of your body adds from the mass of your quarks and gluons and leptons, if you want. But we have no such sum rules. So in physics, we have these sum rules, and ontological reduction is possible in terms of dynamic quantities that have a continuous scale from the Planck scale to the scale of the universe. But there are no such scales, and there are no such sum rules that contain that connect mind and brain. There are no sum rules for
no, not at all. No such rules at all. Yeah.
No,
or maybe
no,
there
no
are
such. If we talk, well, we know that during our conservation here, our brains are consuming energy, and that we need to eat sugar, because the brain needs a lot of sugar to produce to do its work. But if we talk about the energy, I'm feeling so energetic today, we mean something different. Or if we talk about psychical energy, this is just metaphorical talk. We have no scale for that. And so there is a big gap between the qualia of the properties of mental phenomena of our consciousness on the one hand, and the properties, physical and chemical properties of neurons on the other hand, and we have only, the brain research knows only correlations.
Okay, this is the present situation, but maybe one day problem will be solved. Or as a Kantian, you probably think that our knowledge has its limits, and in particular, our knowledge of the physical world has its limits. Do you think that our knowledge has its limits? I
think that these limitations of our knowledge are due to the scientific methods which we employ. And if we employ the traditional analytic synthetic method, that means to take a whole and decompose it into its part, investigate the interactions of the part, and intend to do some kind of mechanistic explanation in order to explain the whole. Perhaps this approach is wrong, or does not help to understand what consciousness is.
Okay, thank you. In your book, Kant's Cosmology, you analyze Kant's pre-critical analytic method to metaphysics. And
yes.
There has been a return of metaphysics and philosophy. Do you think that, in a sense, this is a return to the pre-critical stage in philosophy?
In a certain sense, yes. On the other hand, the colleagues doing analytic metaphysics or formal ontology they know quite well that they are only making theories about how the world could be like. They have toy models of the world at a very general level. On the other hand, Kant's pre-critical metaphysics, I'm participating in a project on inductive metaphysics, which is very critical, together with colleagues from Düsseldorf, Bonn, Cologne, and Münster. And Kant's pre-critical metaphysics was based on inductive methods, indeed. It was close to the inductive methods of Newtonian physics. And anyhow, it went astray, and that's why he had his critical turn, and his pre-critical inductive method went astray with regard to the concept of space. It's quite interesting to study that.
By the way,
so I don't know whether he was right or wrong with throwing overboard his pre-critical metaphysics and developing the critical theory of space and time. But anyway, it's very interesting. But I think there are possibilities to do metaphysics that are not uncritical, even though they do not follow Kant's path.
Okay, thank you. By the way, this inductive metaphysics, is it a mixture of science and philosophy, metaphysics and physics, or is it something like pure philosophy? I think that it's like some mixture of science and philosophy, no? I don't know.
It's a mixture of pure and applied philosophy, I would say.
Okay.
We have 9 or so partial projects. One colleague from Bonn, Elke Brendel, is investigating non-classical logic, for example, as an example of inductive metaphysics, quite interesting. And so this is philosophy applied to logic.
Okay.
Another colleague is investigating the theory of gravitation and the philosophical claims that can be made on this basis. And this is also applied philosophy. And my own project is historical. In the first phase of the project, I studied Kant's pre-critical metaphysics and his inductive methods. And my Kant book is an offspring of this work. And now I switched to neo-Kantianism, and I'm studying the methodology of the neo-Kantians, who say that they are no metaphysicists, but one might quote Hegel, who said, well, the empiricists are the worst metaphysicists because they claim to NAN, to have no metaphysics. And I think the same is true of the Marburg neo-Kantianism.
Okay, thank you. And what is, in your view, the main task of philosophy? Because you spoke about applied philosophy, there is also mathematical philosophy, as now people do it in...
It's also what?
You spoke about applied philosophy.
Yes.
There is also mathematical philosophy. Some people do it in Bavaria, I think so, in München, maybe. And
what do they do? What kind of philosophy?
Mathematical philosophy.
Mathematical philosophy, yes.
What is, in your view, the main task of philosophy? Is philosophy a science?
No. Philosophy of science is just one very large field. But I think the most important part of field, I'm not working in that, is practical philosophy, ethics. On the other hand, the task of understanding nature is also very important, and to understand our position within nature. And this problem of understanding nature has so many facets, and one of them is philosophy of science, another is epistemology, another is constructing toy models of the world, as in analytical metaphysics, and so on. But methodologically, the main task of philosophy is clarifying concepts and arguments and the structure of problems. But this is a methodological task.
Okay, but for you, rather philosophy is rather a critical therapeutic enterprise, not theory construction.
In my own work, yes.
Yeah. Okay.
Yes, but when I have to referee on research projects, I would not stop projects that construct toy models of the world, but would only judge whether this work looks promising or not.
But does philosophy have its own domain of investigation? Because every science has its own domain of investigation. Philosophy is not science, or it is a science.
In terms of the plurality of the sciences, philosophy is belongs to the humanities and is a cultural science.
Cultural science.
On the other hand, in its methods, it's quite close to logic in several aspects. And it is the oldest science from which all the other sciences are an offspring. In ancient Greek philosophy and early modern philosophy as well. And well, what was the point? No, somehow I lost.
The point is, what is the domain of philosophy?
Yes, philosophy now has a very peculiar structure because it is so general. And in our research project on inductive metaphysics, we have a conception of metaphysics that metaphysics is something, metaphysics is philosophy, is systematic philosophy. It is some kind of meta theory of the sciences and of everyday experience as well.
Okay,
so,
alles klar,
metaphysics and philosophy are very general in their topics.
Very general, yeah.
Yes, that's a problem.
What do you think at present are the most important problems in philosophy of science or philosophy of physics? Are there so important problems now? So the most important.
There are many very important problems, and the most important problem is perhaps to find the balance between scientific knowledge and the insight into the limits of scientific methods in times of fake news and corona skeptics. We see on the one hand a big distrust in the sciences. On the other hand, we see that many people have no idea about the meaning of statistics and probability, and this is disastrous, because this is also, this holds, for example, for most professionals in medicine, that they have no idea of statistics and how to apply it, and this is disastrous in the present situation. And on the other hand, we are so dependent on the results of the scientists, which are changing all the time.
Okay,
as always, we cannot predict future. Okay, so
how is it now about the situation with coronavirus in Germany? Is it more or less okay? Or?
The politicians are discussing a lot about how to open a little bit the current lockdown. It's quite difficult problems, and they are very well. They have to make rules, and some of the rules are stupid because these rules have to be general to be applicable. Like in physics, one has to make rules, general rules, and they only apply in very limited cases. For example, there's a general rule for Spain, and I'm at the Canary Islands, and we have a weekly incidence of 34 which is half of the weekly incidence in Germany. But when I go back, I have to make a rapid test, and afterwards I have to go into quarantine. That's the situation. Nobody knows what will happen.
Nobody knows, yeah. Thank you.
Yes, and there are so many problems with children who cannot go to school and all that.
Yeah, that's true, yeah. Thank you. Professor Falkenburg, how do you work? Do you have your own method? Does it take much time to write a book or an article?
It depends. Articles now, after many years of experience, are faster. I need a couple of weeks to write a new article or to rework an older article to make it up to date with its content. And the book on the myth of determinism on neuroscience was very fast. I needed 2 years more or less from the very first beginning until it went into press. But it was also based on a lot of experience in philosophy of science, obviously. But my books on particle metaphysics and on Kant's cosmology both had a German predecessor. And from the very first work on the German predecessors to the definite English versions that were at least half books with a completely new content, I needed 20 years each. Well, so I did not, I cannot write one book after the other because I'm not yet doing 40 years of professional philosophy. So this was in parallel.
Okay, thank you. Professor Falkenburg, and what are your philosophical projects?
I want to go on with neo-Kantian philosophy.
Also, in general,
yes.
Your philosophical projects, yeah.
Yes, yes. No, wasn't that your question?
What are your philosophical projects? What are you going to write, to publish? What are your projects?
3 books. The first is a translation, the translation of Erhard Scheibe's reduction of physical theories. I'm working on that together with Greg Jäger from Boston University. And the other 2 book projects are related to neo-Kantianism on the one hand and to philosophy of physics. On the other hand, well, physics is the intersection, obviously. And the book on the neo-Kantian philosophy of physics should cover the beginnings in the Marburg school and then switch to the Bohr-Heisenberg school and more recent approaches, and above all the work of Peter Mittelstädt and also Erhard Scheibe, but also other approaches that I have to compare with them, like Michel Bitbons. I have to look into his work again. I did not in the last time. So this is quite a comprehensive project. But the other project is a continuation of my edition on astroparticle physics. I have for almost 2 decades now a collaboration with the physicist Wolfgang Rode from Dortmund University, and I would like to make a project with him and perhaps a colleague from philosophy of science from the TU Technical University Berlin on the role of machine learning in astroparticle physics, because I think that the methods of machine learning in particular and all the experiments of astroparticle physics together with the experiments of particle physics in general dramatically changed the relation between theory and experiment, and I would like to understand a little bit more of that.
It's fascinating, yeah. Professor Falkenburg, thank you very much for this interview. It was my pleasure to discuss with you. Frau Professor Brigitte Falkenburg, vielen Dank für dieses Interview. Es war mir eine Freude, mit Ihnen zu diskutieren. Alles Gute für Sie und für Ihre Forschung. Auf Wiedersehen.
thank you so much for giving me the opportunity to reflect a little bit on what I'm doing in philosophy and what's important about that, perhaps. Thank you very much for this interview, too.
Thank you for you. Bye-bye.